So, welcome to module 6.4. In this module, we will understand how powerful is the VM. So, we will actually take two examples from common programming languages. Actually, in module 6.3, we actually translated a C function into VM, but now we will do something a little more complex than that to show the power of the VM instruction set. So, we will take two examples. One is namely array handling and another is object handling. Now, let us say we have an array called bar, right, and we are going to set that bar, the second element of this bar to 19, right. Now, in practice, what will happen is in C, now bar itself will be mapped on to some location, say 500, which will point to some 4000. In this 4000, bar 0 will be stored, 4001 bar 1, 4002 bar 2. So, essentially what we have to do is we need to go to the location given by bar. Bar is mapped onto 500. We need to go to that location, that is 500, get that value 4000, add the index 2, so you get 4002. In 4002, we need to go and store 19, right. So, this is how the whole thing has to work. Now, let without loss of generality, let us assume that bar is so in this function, whatever, let it be some main. Bar is your first variable, say let us say int bar 100. So, what it stores, it stores the bar is the first variable, right. So, what we do is, so in local segment, right, this is in local, bar is a local variable, right, local segment 0th location bar is stored. So, what we need to do is, first we have to get, right, 4002 and then store something there. So, push local 0. That means the value of bar will be stored in the stack, that is 4000 will be stored. Now, I push constant 2, essentially 2 also will go there. Now, I add. So, now I get 4002 because local 0, local variable 0th locations bar, bar's value is 4000, always the variable will store the starting address of the array. Now, I have pushed constant 2, so 4000 plus 2, 4002, I added this, so I got 4002. Now, I have to store in the location 4002 the value 19. Now, what I do is, I pop, so what will be on top of the stack? Now, 4002, because I pushed local 0, 0 will be on the top, then I push 2, push local 0, so 4000 will be on the top, then push constant 2, 2 on the top. When I said add, 4002 will come, 4002 will be on the top of the stack. Now, what I am doing now is, I am popping this value, popping this into what we call as pointer 1, right. Now, for the use of the function, we have two general purpose memory segment. One is called this, another is called that. So, in your entire RAM, this and that will occupy some k locations, k1, k2 locations, right. So, this is a segment, that is a segment, this and that are different segments. These can be used for any general purpose. Now, somebody has to point to the start of the segment, and that is pointer 0 and pointer 1. Pointer 0 and pointer 1 will actually point to the start of this segment, namely this and that. So, when I say pop pointer 1, that means 4002 is now pointer 1. Essentially, that means 4002 is the that segment now. So, your that segment now starts at 4002, right. Now, I am doing push constant 19. So, 19 is on the top of the stack. Now, I say pop that 0. The moment I say that, where is the start address of that? That is given by pointer 1, that is 4002 and 0 is the index. So, 4002 plus 0, 4002. In 4002, I need to go and store 19. So, this is how the entire thing works. So, what I have done, this is a main routine, I have int bar 100. So, the bar is the first local variable, 0th local variable, which is stored in the local segment at 0th index. Now, I want to make bar 2 as 19. So, when I say local 0 basically has the address of the start of bar, in this case it is 4000. Now, I push that address into the stack. So, my stack, let me just show you the stack, how it is going to go here, so that we have a very good understanding of this. So, now in the stack I will have 4000 because of this push local 0. Now, I am pushing constant, which is 2. Now, I am adding it, basically now this becomes 4002. Now, I am popping this 4002 into pointer 1. So, pointer 1 will get 4002. Pointer 1 always points to the base address of the that segment, and this and that are basically temporary segments. So, pointer 1 will always point to the base of that. Pointer of 0 will point to the base of this. Correct? Now, I pop pointer 1, that means a pointer 1 got 4002. So, this is gone because I have popped it out. Now, I am pushing constant 19. Now, I pop 19 to that segment's 0th index in that segment. So, where does the that segment start? It starts at 4002 because pointer 1 gives you the start of the that segment. So, in 4002 plus 0, this is the index, 4002 plus 0, that is 4002. In 4002, I will now pop this 19 and store it in 4002. So, that is how I get bar 2 equal to 19, right. So, this example is very simple example, but what we need to understand is about different segments, etc. So, we have learned what is that, what is this, what is pointer 0, what is pointer 1, what is constant, what is local. Some of the things like argument, etc. we saw in the previous example, in the previous module. Now, we are now seeing this in some detail. Okay. Now, the next thing is we will also discuss the power of this VM by understanding what object handling. Suppose I have an object called ball, which has a radius and a color can be, and it also has the so we are now trying to make a game. So, this ball is moving on the screen, so it has xy coordinate. Let us say xy are also integers. So, a ball B, so we are now making is an object, we are now trying to do a game with all these balls floating around here and there, and so this ball B is an object, and it has an x coordinate, it has an y coordinate, and then it has radius, and it also has color. There can be multicolor. right? So, normally let us say these are all int just to make it comfortable. So, in C we write it using a structure. This is in C. In C++ you can actually use a class and instantiate an object, right? Nevertheless, in both cases, if I just say B will give me the address where it is stored. For example, so let us say I have a function, let us say my func, in this I have ball B, right? Now essentially what will happen is B is an address. So B is mapped down to say some so without loss of generality 500. So this is B. Inside B I will store some 1000. So in 1001 I will have X, 1002 I will have Y, 1003 I will have radius, 1004 I will have color. So this is how this particular object is mapped down to the memory. Now B is a local variable. So let us without lots of analogy say that in the local segment 0th location this B is stored. So local segment 0th location I will get 1000 there. From there I have to go and calculate. Suppose I want to set the radius to R. So suppose I have a function called set radius B comma R. B is a ball and R. Now I have to set B dot radius is equal to R. Suppose I want to do this. So B, the address B is coming in and I am getting an int R. So I have to set B dot radius is equal to R. Now what is B and R? B and R are basically arguments, right? So in the argument section, in the 0th location, B's base address will be stored. B will be stored. That means 5000 will be stored. In the 1, the new radius R will be stored. Push argument 0, I pushed 1001 inside because argument 0 is B, sorry, it should be 1001. I pushed 1001 inside and I popped it to pointer 0. So that means the base of my this segment is now pointing to 1001. Now I push argument 1, argument 1 is R, so I push 10 into this. Now I pop that 10 into this segment with index 2. This segment is pointing to 1001, 1001 plus 2 is 1003, so this 10 gets assigned to radius. So this is how we make B dot radius is equal to R. So essentially I am having two arguments B and R. B is nothing but the base address of the structure which stores the details about the ball. R is an integer which is the radius. So the base address of the structure which stores the details of the ball, in this case 1001, is stored in argument segment 0, and argument segment 1, which is the first argument, which will store this 10. Now what I do is I push the argument 0, that is 1001, onto the stack, and then I pop it to pointer 0. That means 1001 comes to point to this. So that this segment's base is pointer is now 1001. That means this segment essentially points to the ball B, right? So, right now I push argument 1. Argument 1 is R for me, so I am pushing 10 into the stack, and now I say pop this 2. So this now is pointing to the ball, that is 1001. Now when I pop this segment plus 2, that is 1001 plus 2, 1003. So I pop the value 10 onto this radius, which is 1003, right? So this is how we do this. So essentially Now we can handle objects, we can handle arrays. We have given two interesting examples which are not very trivial in terms of realization, and but we have realized this. So to sum up this particular module, let me just go ahead and tell you what are all. So we have two memory access functions that we have seen. One is push segment index and pop segment index. So what are these segments? The segment can be argument, the segment can be local, the segment can be constant, wherein this is a 15-bit positive constant in the range 0 to 32 767. So this is the range. It can be a constant, right? So the index of this constant should be just a 15-bit number. So my argument local we have already seen. Then I could have pointer. This will go and update. So pointer 0 will update. If I say pointer with the index 0, this is the index, pointer with index 0, then it will update base of this segment. If I say pointer 1, it will update base of that segment, and this and that can be used for all temporary computations as we had seen in the previous example. Then I could have temp, which is just maximum 8 locations, that is index 0 to 7, which I can use for some temporary computation if needed. Then I can have this comma that. So if I say push this comma 5, it will go to pointer 0, that will give you the base address, that you will add 5, and what, so that let us that base address be 1000, so 1005, I will get that 1005. In that 1005 there is some say 512 as a content, that 512 will be now pushed onto the stack. That is what it means, right? Push this comma 5. Similarly I can say push that comma 5. Similarly pop this comma 5, pop that comma 5. So this comma that. Then I could also have static, because as a function I would have some static variables. Static variables will be stored separately. So I could have. So essentially you are seeing now 8 such segments, 8 such things that can go as segment. Each is some separate, as far as the function is concerned, each is a separate part of the memory, and each is a separate segment, and each has its own base address, and we need to access from that base address plus an index. So this gives us a concept of what you will learn in your computer organization course as memory segmentation. Already when we designed the architecture, we have two segments, two memories itself, one ROM and another RAM. I hope you remember. This ROM is basically storing code, RAM is actually storing data. So this is code segment. So we have already segmented it. Well, RAM is data segment, and inside the RAM is what you could have several such segment for every function, right? Now just to just keep in mind that when we constructed the symbol table, we had things like LCL, ARG, etc. Now some bell should ring. This is argument local. So for every function that we are compiling, the base address for your argument, the base address for your local segment, the base address for your temp segment, etc. will be stored in these variables like LCL, ARG. We will see how it is going to be done, Right. So what we have done so far, so we have understood the 17 instructions of the virtual machine. 9 of them are basically the arithmetic logic instructions. We had 2 memory access and 3 each of your program flow and the program flow and the function calling instructions. And so hopefully this gives you an understanding of how the VM works and also the power of a stack based virtual machine. So what we will do in the subsequent 2 modules is that we will see how these instructions are basically, each one of these instructions, we will take add, we will take all the ALU instructions, all the function calls, all the memory calls, memory access, all the 17 instructions. Each of these 17 instructions, how I can translate into the corresponding mnemonic, and that is what we will start seeing in the next 2 modules, module 6.5 and module 6.6. Hope you understood this. I have tried my best to explain. So there can be still doubts, so don't give up. Please do put your queries on the discussion blog, and we will basically answer these queries. And also don't repeat the queries. Please check if your query is already answered in the discussion blog. If it is answered, then you can take it. If it is not answered and it's a new query, you are always welcome to put that query. So this will help us to optimize answering queries, and so that we could do more justice to each query rather than answering 1000 similar queries. If I answer once but I do a better answer for that, I think it will be much more useful. So all the best with your understanding of this VM. I hope you have completed your assembler project. That's very important for us to now start understanding the remaining 2 modules. So please do start your module 6.5 right after you complete your assembler project, right? Thank you.